Hi, I'm Siti Aisha and I'm going to present about the Archimedes principle. Archimedes' principle stated that the upward buoyant force that is exerted on a body immersed in a fluid, whether partially or fully submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of the mass of the displaced fluid. By using this Archimedes principle, we can measure the buoyant force of different objects in water by using the formula Fb is equals to rho gv. We can also use this formula to measure the volume of the irregular shaped objects. Next, we can measure density of the different objects. There is two methods of calculation, which are direct method and also displacement method. The objective of this experiment is to measure the buoyant force of two different objects in water. Next is to determine the relationship between volume and the buoyant force, and lastly to measure density of the two different objects. This is the setup of experiment, which include the spring balance, object, container, beaker with spouts, digital scales, and also the displaced water. For the methodology, first, hang the object from a hook connected to the spring balance and read the weight. Place the beaker with spout under the object. Fill the beaker with water until water runs out of the spout. Lower the object into the water while collect the displaced water with a container. Continue lowering until object is completely submerged. Take the reading of the spring balance and calculate the apparent weight of the object. Using digital scale, measure the mass of the displaced water and calculate its weight. Don't forget to subtract the mass of the container. And lastly, repeat step 1 until 5 for the other object. Dry off the inside of the container each time to get more accurate result. So here is the result. Here I compute two types of metal, which are copper and also silver. For the data tabulation, I include mass, weight in air, weight in water, weight of the water displaced, density, and also the upward force. To measure the buoyant force, for the direct method, we can use the formula upward force or buoyant force is equals to the weight of the object in the air minus weight of the object in the water. For the displacement method, the formula is buoyant force is equals to the mass of the water times the acceleration due to the gravity. For this experiment, the volume of water used is 25 centimeter cubed. From the result, we know that when we immerse the object into the water, the weight of the water displaced is equal to the upward force. Or in the other word, we can say that loss in weight is equals to the upward force. Then, the buoyant force of the two objects are the same. This shows that the density of the object do not affect the buoyant force. To calculate the density of the object, we can use these three formulas. Rearrange them to get this last formula. Then just enter the value and you can calculate the density of the objects. Here is the information related to the formulas. For the conclusion, we can say that the theory is valid, which is upward force or buoyant force is equals to the weight of the water displaced. In the other hand, we can say that upward force is equal to volume of the liquid times the density of the liquid times the acceleration due to the gravity. From this formula, we can conclude that buoyant force depends on first, the density of the fluid, and the second, the volume of the object, which also means that the higher the density of the fluid, the higher the buoyant force, or the higher the volume of the object, the higher the buoyant force. That's all from me. Thank you.